Alright class, good day. You're welcome once again to Maestro Science Guide. Now if you're seeing this channel for the first time, this is an educative channel for science students, alright, offering chemistry, biology, physics, alright. Now we're going to be looking at something interesting in today's video, and that is the Graham's law of diffusion. Now the Graham's law of diffusion is it's a law under the gas law, alright. The gas laws, we have so many laws: Boyle's law, Charles law, pressure law, general gas equation, ID gas law, and so on and so forth. All right, we are going to be concentrating on the Graham's law of diffusion in today's video. Now, what does the Graham's law of diffusion simply state? It states that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its density. The rate of diffusion or effusion of a gas is inversely proportional to the square root of its density. So that simply means the rate of a gas is inversely proportional to the square root of its density. Alright? So it therefore means that the higher the rate of a gas, the lower the density. So a gas with a higher rate, we have a lower density because inversely proportional. And a gas with a higher density, we have a lower rate. So this one is telling us that the rate is high, so therefore density will be low. Right? If we decide to change it, if we say density should be high, then therefore means that the rate of the gas will be low. So this is what we have. Then density, we can also use, in place of this density, we can also use molecular mass, right? So if the rate of a gas is inversely proportional to density, it's also inversely proportional to the molecular mass. So therefore means the lower the molecular mass of a gas, the higher the rate. So that is the reason why hydrogen will diffuse faster than what? Chlorine. Why is that so? Because the molecular mass of hydrogen is small compared to that of what? Chlorine. So this one is going to have a higher rate. Hydrogen is going to have a higher rate of diffusion, and chlorine we have a lower rate of diffusion, comparing it to hydrogen. So to give us the formulas that we need, all right, we have arrow. First of all, we have rate is equal to volume over time. All right, seconds. Volume is centimeter cube over what? Time, seconds. Okay, so this is one important formula of rate you need to know. So what this formula is telling us is that rate is directly proportional to volume and inversely proportional to what? To time. So that's what this formula is giving us. Then other formulas on the Graham's law of diffusion. So in relating all of them, we have R1, R2 of a gas is equal to root M2 over root M1, which is equal to root D2 over root D1, which is also equal to V1 over V2, which is also equal to T2 over T1. So these are what we have as regarding the Graham's law of diffusion. So now where we are going to apply these formulas is in the case of questions. Now in question scenario, you have to be very sensitive. First of all, ask yourself, what am I looking for? So it's from what you are able to find and the parameters you were given. That will now depends on which of the formulas say you need to incorporate. Sometimes you might only require to use this and this. Sometimes it could be this, this, and this. Sometimes it could be this and this, and all of those stuffs. All right. Now, please, I want you to stay tuned to the end of this video lesson, and I want you to pay close attention. The reason is because I'll be dropping a secret shortcut formula in just a moment. So please make sure you follow up. All right. Make sure you follow up, and do it to smash the like button if you are already gaining information from this video. All right. Now let us go into questions. All right, class. Now we have example 1 on the board. Now let us break down example 1. It is very, very easy. It is very, very easy. Now look at the question. It says if 1.0 gn cube of gas X diffuses through a porous plug in 60 seconds. So now listen, we are given the first volume. So our V1 is 1.0 dm cube. Then we're giving our T1, our first time. So T1 is equal to what? 60 seconds. While the same volume of hydrogen, so the same volume of hydrogen. So our V2 is still 1.0 dm cube. Then hydrogen diffuses in 15 seconds. So our T2 is 15 seconds. Now we're supposed to look for the molar mass of gas X. Remember, gas X was the first to be mentioned. So therefore means that the molar mass of gas X will be taken as what? Our M1. So our M1 is the molar mass of gas X. So we are looking for what this X stands for. Then hydrogen, which the atomic mass is 1. So our M2, that of hydrogen, is simply hydrogen. And now hydrogen, we're giving one here, but we are not working with this one. Why? Hydrogen is a diatomic molecule, right? It's diatomic. That is why it is H2. So it has H plus H. Alright, so 1 plus 1. That gives us 2. So the molar mass of hydrogen is what? 2. So now we've known all this. Now we cannot just start solving with this dm cube. We're going to change it to what? Centimeter cube. Right? We're going to be working with centimeter cube. So we convert this to centimeter cube. What do you get? 1000 cm cube. Convert this to centimeter cube. What will you get? 1000 cm cube. So now, very easy. What do we then do at this juncture? At this juncture, what we simply do is that we are going to use a shortcut. Alright? There's a shortcut I developed. Okay? This shortcut is going to help you with this question. If you want to solve straight with this question, you are going to take time. You're going to exhaust time and energy. But with this shortcut, you are good to go. Now, what's the shortcut formula? V1 times T2 all over V2 times T1. Alright? Equal to root M2 over root M1. This is the formula we are going to be using for this question. Alright? It will give you your answer fast and sweet. Okay? So this is the master's formula. I like to call it the master's formula. Master's formula. Now, the only limitation now, not really limitation, the only way you can use this formula is when you are giving volume and you are giving time. Or better still, they tell you find volume. You have 2 times. You have 1 volume given. You know your molar mass. This is the best formula to do it. So it therefore means that in order to use this formula, there are 3 things you must know. You must know at least 1 of the volume. You must know at least 1 of the time. And you must know at least 1 of the molecular mass. If you look at this question, we know the volumes, the V1 and V2. We know the T2 and T1. We know our M2, which is 2. But we do not know our M1. So there is only going to be 1 unknown. Alright? So this formula works best. Alright. So now let us input all our values into it. Now, when you do this, we have 1000 times, what are T2? 15 all over. What's our V2? V2 is still 1000 times, what's our T1? 60 equal to root M2. M2 is hydrogen, and the molar mass of hydrogen is all 2 all over. What's M1? That's what we are looking for. So root X. So obviously 1000 cancel out 1000. What do we have? 15 all over 60 is equal to root 2. In fact, if you do root 2 with your calculator, you're going to get 1.414 all over root X. So at least, what do we do? Cross multiply. So by the time we cross multiply and we now divide, we are going to arrive at root X is equal to 60 times 1.414 all over 15. Right? So by the time you cross multiply, and you now divide both sides by the number carrying the root X, this is what you are going to arrive at. Now, if you just put this, let's put this into our calculator right now. So we're going to have this 60 times 1.414 414 is equal to this divided by 15. So what we actually have is 5.656 with x is equal to 5.656. But is it our final answer? No, this is not our final answer. Now we are looking for x, not root x. So how do we remove this root, this square root? We simply what now? Take the square of both sides. To eliminate the square root, we simply square both sides. So by the time we square both sides, by the time I decide to square here, and I square this guy, all right? Decide to square. So this square cancel this square root. This lost this square root. So we have only x is equal to, now square this 5.656. When you square that, you are going to have 31.99 gram per mole, which is the molar mass of x. So it therefore means that the molar mass of x is 31.99 gram per mole. Right, that's the SI unit for molar mass. All right, now let's go to example 2. You can see how easy it is, right? So please, if you are getting information from this video, please do it to subscribe and hit the like button so that this video can get to others. Now let's go to example 2. For 2, it says an oxide XO2 has vapor density of 32. What is the atomic mass of X? So an oxide has vapor density of 32. What is the atomic mass of X? We're looking for the atomic mass of X. So now we're given vapor density. Please note that vapor density is equal to molar mass divided by 2. All right. So if we're giving vapor density to be 32, how do we not get molar mass? So just impute your vapor density. Here we have 32 equals the molar mass. Let's just call it y all over what? 2. So by the time we cross multiply, what do we have? Y times 1 is what? Y equal to 32 times 2. 32 times 2 is what? 64. So our molar mass is 64 gram per mole. That's our molar mass. 64 gram per mole. So now let us find the atomic mass of X. It's very easy. Very easy. How do we do this? So we know that the molar mass of this entire compound, of this entire oxide, right, this compound, we know that it is XO2 equal to what? 64. Now remember we are giving oxygen 16, but there is 2 here, so that becomes X plus 16 times 2 equals what? 64. 16 times 2 will give us what? 32. So therefore we have X plus 32 equals 64. At this point, what do? We simply what? Collect like terms. So when we move plus 32 this way, we have what? X is equal to 64 minus what? 32. 64 minus 32, that is X is equal to what? 32. So the atomic mass of X is 32. Okay, class. Now let us break down question 3 on the board. Let us break down this question 3. Very simple. Now question 3 says, a given volume of oxygen diffuses through a porous plug in 8.0 seconds. How long will it take the same volume of sulfur oxide to diffuse through the same condition? Now, when looking at this question, just try to recollect. We are going to use my master's formula, all right? The master's formula, that shortcut formula that saves time, energy, and also produce what? Accurate answers. All right. So first of all, let's look at our parameters. A given volume of oxygen diffuses. Okay, so the first volume is B3. So we have our T1, 8 seconds. So our T1 is 8.0 seconds. Then how long will it take the same volume of sulfur oxide to diffuse through the same condition? So how long? That's T2, right? T2. So and our T2 is don't know. Then sulfur, the molar mass. So what's our M1? What's the first one mentioned? Oxygen. So we'll call it what is the molar mass of oxygen? Oxygen is diatomic O2. So it will be what? 32. It's O2, that is 16 times 2, which will give us 32. Then sulfur is our second one, right? So sulfur, pay attention. Sulfur is SO2. So that is sulfur 32 plus O2 is what? 32. So this plus this, that will give us what? 64. Alright? Gram per mole. Alright. Then a given volume. So we can assume at this point, we'll just assume that it is 1 centimeter cube for both of them. So V1 is 1 cm cube. V2 is also 1 cm cube. So using the shortcut, we have V1 times T2 all over V2 times T1 equal to root M2 over root M1. Remember, we are looking for how long will it take, okay? How long? So that's T2. So what our V1 so is 1 times T2 all over, what our V2? 1 times T1. T1 is what? 8 equals root M2, 64, that's root 64 all over, and M1 is what? Root 32. So this time this will give us T2, then all over 8 equals, now what's the square root of 64? In doing this, if we're going to press our calculator right now, the square root of 64, that will give us what? 8. And then the square root of 32, that will give us 5.6 5.656. So from here, what do we simply do? We simply will cross multiply and divide, all right? So by the time we cross multiply 8 times 8, T2 times this, okay? So when we do this, we are going to have 5.656 T2 equals to 8 times 8. 8 times 8 is what? 64. So we have 64, then 5.656 T2. At this point, what do? We simply divide both sides by the number carrying the alphabet. So divide both sides by 5.656. Why are we dividing both sides by 5.656? Because 5.656 is the number carrying what? The alphabet, which is T2. So by the time we cancel out and cancel out, therefore T2 will not be, when we do this, 64 divided by 5.656, what we are going to get is 11.31 seconds. 11.31 seconds. So that's our answer for what? T2. Now, some of you might want to ask, how come why did I choose to use 1? Now, you can use any number. All that matters is that, listen, all that matters is that the volume of the oxygen that you want to use, the number you want to use, make sure it is the same with the one you will use for sulfur. So yeah, you can decide to use 100. You can assume your V1 to be 100. For sulfur, that's your V2. You must also make sure it is what? 100. You can decide to use 50. You can even decide to use 2 or 5. Alright? Why are you using this? Simply because you were not giving the exact value of the volume. You are not giving the exact value of the volume. But you were told that the same volume of oxygen is the same for what? Sulfur. So any number you want to use for oxygen, make sure you use that same number for the sulfur. So that's why you say I put 1, use 1 for oxygen. That's 1 centimeter cube of oxygen, which is our B1. Then I also use 1 centimeter cube of SO2, which is our B2. Now let us go to the last and final question, which is example 4. Now let's look at the final question. All right. Now the question says a gas X diffuses twice as fast as gas Y. If the relative molecular mass of X is 32, calculate the relative molecular mass of Y. So now we're given a rate. We said gas X, the question, gas X diffuses twice as fast as Y. So the rate at which X diffuses is times 2 of Y. So we can say our arrow X should be 2, then our arrow Y should be what? 1. Why? Because we're told that gas X diffuses twice as fast as what? Gas Y. So if we decide to use 2 arrow, if our arrow Y, we decide to work with 2 for our arrow Y. So twice of 2 will be what? 4. If we decide to work with arrow Y to be 1, twice of 1 will be what? 2. So whichever. So we can either use 4 for our arrow Y and use 2 for our arrow X, or we use 2 for our arrow Y and use 4 for our arrow X. But all that, one thing you just need to pay attention to is the fact that X diffuses twice as fast as Y. So Y is when anything you have in Y times it by 2. Alright, we give you your X. So your X is times 2 of Y. Alright, so the relative molecular mass of X is what? 32. So our M1 is what? 32. How do I know X is M1? I know X is M1 because X is the first gas that was mentioned. The first gas mentioned is your 1. Alright, is the first one. That's your 1. Then in the case of time, the first time mentioned is your T1. The second time mentioned is your T2. The first volume measured is your V1. The second volume measured is your V2. Okay, so please don't forget. So they say we should find the relative molecular mass of Y. So that is, this one is the last one to come. So call it what? M2. So that's Y. So simple. How do you solve this? Just use that formula. R1 over R2 equal to root M2 over root M1. As easy as this, right? As easy as that. So X is our 1, so that's 2 over arrow 2, that's our Y. Because I told you 1 is the first gas mentioned, but 2 is the second gas mentioned. So the second gas mentioned after X was what? Y. So our Y is what? The arrow 2, which we put as what? 1 equals root M2, that's root Y all over what? Root 32. Last, from this point, what do? Cross multiply. So by the time we cross multiply, we are going to have what? 1 times root Y equals 2 times what? Root 32. So if we break this, 1 times root Y is what? Root Y equals, now if we break down root 32 in our calculator, root 32 in our calculator is 5.656. So that's 2 times 5.656. So 2 times 5.656, that will give us 11.3. 11.3. But now we were told to look for Y, not root Y. So what do? We square both sides. So our root Y, we square it, equal to 11.3, not just 11.3, 11.313. Okay, so we also want square this. So square cancel out square root, therefore Y is equal to, so in our calculator, 11.313 square, that will give us 127.9, approximately 128 gram per mole. So this is our answer. So thank you very much for watching this video up to this point. God bless you. I really appreciate you. Please, if you have not subscribed, please do well to subscribe, like this video, and I'll see you in the next lesson.